Welcome back. In the previous video, we performed a second line trace from the barrel to the point we're aiming at to see if an object was in the way between the barrel and the impact point. Now the code in shooterCharacter.cpp is getting a little unwieldy in the fire weapon function, so we're going to do some refactoring. A lot of this work has to do with getting the beam end location and updating that with line traces and such. So what we can do is create a function to take care of getting the beam end location. We're going to declare this function here in shooterCharacter.h, and we'll put it here in the protected section. Let's have this return a bool so that we can return the success of getting our beam end location. Let's call this get beam end location. Now, in order to get the beam end location, we first need to pass in the muzzle socket location. We can pass this in as a const f vector reference. And this will be called muzzle socket location. And finally, we need to get that beam end location, so we can pass that in as a reference that's not const, so our function can change it. So this will be an f vector reference. And we can call this out beam location. We're calling this out beam location to indicate that even though this is an input parameter, it's really an output for the function, because we're going to change it to the beam end location that we calculate in this function. Let's hover over this and click the icon that pops up to get Visual Studio to create a definition for this. And in shooterCharacter.cpp, we'll find our definition. And you'll see that Visual Studio created a definition that just returns false. Okay, we're ready to script this out. Now, because I'm using such a large font, I'm going to go ahead and put these input parameters on their own lines so we can see this a little more clearly. Okay, we're going to construct this get beam end location in baby steps. Let's go back to our fire weapon function. In fire weapon, we first play the fire sound, then we get our barrel socket, we get the socket transform, we spawn the muzzle flash, and then we start doing things that pertain to getting our beam end location. First, we get the size of the viewport. This can go in our get beam end location function. So let's copy it and go back down to get beam end location, and let's paste it in here. So we're getting the current size of the viewport. Let's go back to fire weapon. After getting the current size of the viewport, we then get the screen space location of the crosshairs. We can also take this and stick that in our new function. Here's our new function. We're getting the screen space location of the crosshairs. Let's return to fire weapon. After we get the screen space location of the crosshairs, we then get the world position and direction of the crosshairs by calling dproject screen to world. We're going to copy this and also put it in our new function. Okay, now back to fire weapon. Okay, next what we do is check to see if the deprojection was successful. If so, then we start doing our screen trace hit, and this is where we create the beam endpoint. In our function, we initialize it to the same endpoint that we're going to pass into line trace single by channel. If there was a hit, we set our endpoint to the line trace endpoint, and then we perform our second line trace. So we can take this entire if statement that starts with if bscreen to world and copy the whole thing, and if we come down and paste it into our new function, then all we need to change in this if statement is our beam endpoint. Instead of creating a local variable, we can set our input parameter called out beam location. So if screen to world, we create our f hit result, and we create our start and end for the line trace. And then instead of creating a local variable called beam endpoint, we're going to set out beam location equal to end. And we no longer need this local variable endpoint. Now scrolling down, we'll see that after we trace outward from the crosshairs, if there's a blocking hit, we update the beam endpoint. We need to replace this with out beam location, our input parameter vector. Scrolling down more, we'll see that when we're ready to perform our second trace from the gun barrel, the weapon trace start needs the socket transform. And that's why, if you'll scroll up to the beginning of our function, our first parameter for this function is the muzzle socket location. We're going to use this F vector. So scrolling down, our weapon trace start is going to be initialized to muzzle socket location. And our weapon trace end is going to be out beam location. And our weapon trace end, instead of beam endpoint, is going to be out beam location. Now finally, after our second line trace, if there was a hit, we need to update out beam location. So instead of beam endpoint, we have out beam location. Now, we don't need to spawn the impact particles in our function because this function is only about getting the out beam location. We also don't need to spawn the beam particles. We can take these out of this function because we're going to do this outside of this function. So take those out. Now, by default, this function returns false. But if we scroll up, if B screen to world is true, then we at least got the D projection for our crosshairs, which means we're going to set our out beam location at least to the endpoint of that line trace. And depending on the line traces to come, out beam location may be updated, but we at least know it'll be initialized with some value. So if B screen to world is true, we can go ahead and return true, but if it failed, then by default we'll return false. Now I don't expect us to ever return false, but if that deproject screen to world ever fails, then we will get false because out beam location will not have a valid value. Okay, so now we have a function called getBeamEnd location. Let's go back up into fire weapon. Just after if muzzle flash, we no longer need to get the current size of the viewport. We can delete this part. We no longer need to get the screen space location of the crosshairs. We no longer need to get the world position and direction of the crosshairs. And we don't need to deproject the screen to the world. So I'm going to go ahead and collapse this whole if statement and delete it. And all of this commented out code here is dead code. So I'm going to collapse that out and delete it as well. Now what's left here is to get our beam end location. Let's go ahead and create an F vector and call it beam end. And then we'll create a bool called beam end and set it equal to the return value from get beam end location. Get beam end location takes our socket transform location. So that's going to be socket transform dot get location. Let's go ahead and put this on the next line. Our next parameter is called out beam location, and we just created this beam end, so let's pass that in. Now we can check to see if beam end is true. If so, then beam end will have a valid location. Once we have this beam end location, we can use it to spawn the impact particles and the beam. So let's do that. First we'll deal with the particles. We'll say if impact particles, then we'll call gameplay statics spawn emitter at location, passing in get world, impact particles, and the location, which will be beam end. After spawning the impact particles, we can take care of our smoke beam. And to do that, we created a local variable called beam. So we'll do that again. It's particle system component called beam. And we're going to call gameplay statics spawn emitter at location, passing in get world, beam particles, and socket transform. And next, we check to see if beam is valid. If it is, we'll set the vector parameter for target to the beam end location. So beam set vector parameter, passing in the F name called target, and the F vector param is beam end. So now fire weapon is looking a lot better. we're simply playing the fire sound, getting the barrel socket, getting the transform from that socket, and creating the muzzle flash. Then we get our beam end with get beam end location, which was a whole bunch of code we refactored into one little function. If that's successful, then we spawn the impact particles and the beam particles. And that's it. The only thing left in Fire Weapon is to play the animation montage. So there's still kind of a lot in this function, but it's looking a lot smaller. So that concludes this video. In summary, we refactored our code for getting the beam end location all into one neat, tidy function. In the next video, we're going to start taking care of strafing movement behavior for our character, because when we press play and move sideways, the character still looks like she's trying to move forward instead of sideways. So we'll start implementing that in the next videos. See you soon.